Okay, so today we're going back and forth. We are going to learn how to convert fractions to decimals. Your calculator is a tool to help you, but also I want your brains to be able to do it without it. First thing to warm up, fractions are just division statements. The line in the middle means to divide. I know that it's a little bit faint on this one. If you have 1 over 2, that means 1 divided by 2, what does that become as a decimal? River? 0.5. 1 divided by 4 is? Yeah. 1 divided by 10. Good. And last one's a little bit trickier. 1 divided by 8. Good. Now, every single one of those decimals, did it go on forever? No, it just stopped, didn't it? Do you remember what the word is when something just stops as a decimal? It starts with a T. Yeah, good. They're terminating decimals. The way I remember that, you guys are all a little bit young, but the Terminator, do you remember the Terminator? Yeah. Arnold Schwarzenegger? Yeah. He stopped the bad guys, yes? He comes up to these decimals, they'd go on forever, except the Terminator comes and stops them. Once he stops them, do they keep going? Yeah. No, they just end. Okay, so they're terminating because the Terminator made them end. Mac, are we good with that? Have you seen the Terminator movies? No. Yeah, that's a real blast from the past. Okay. The Terminator, much like a superhero, cannot be everywhere all the time. So some decimals are going to go on forever and ever. They are called repeating decimals. They could also be irrational decimals, but today we're going to deal with just the repeating ones. I want us to look for some shortcuts here. Now, 5 over 11, can you type that into your calculator right now? Sydney? It's 0.45. Good. So the decimal or the short form, we don't want to write 0.45454545454545, and we'd never get to stop. How can I show that that decimal is going to repeat? Put a line, and I put a line over everything that repeats, so the 4 and the 5. Now, interestingly enough, and I want us to look for some patterns, the period or block of repeating digits in this one, would you agree it's the 4 and the 5 that repeat? So you would just say it's the 4 or 5, and that's 2 digits long. Okay. Just out of interest's sake, is there any way to turn the original 5 in that fraction into a 4 or 5? Like, is there any way to turn a 5 into a 45, like by multiplication? 5 times 9. Now, there's a rule with fractions. I didn't make it up. I don't know who made it up. The math gods. If you do it to the top, you do it to the bottom. And that would get me 45 over 99. Now, I know you're thinking that really doesn't help anyone, but it might in a moment. It has the 45, so it maybe gives us a hint. Can I change the second one? Say yes, Mrs. Brown. You already did it? Oh, sorry. I want to change it to 1 over 9. You are allowed to as well. Yeah, I think we're going to see the pattern better if we do it. So there's this is not me being super random. There's method to this madness. What is 1 divided by 9? 0.1 repeating. Which number repeated? So the period or the block of repeating digits was just the, and there was just 1 digit that repeated over and over and over again. Okay, what about 8 over 9? Good, 0.8 repeating. And the thing that repeated was the 8, and it was just 1 digit long. Okay, I got to change the last one. Sorry, not sorry. Miles, your favorite number less than 100? 54, I like it. We are going to change this guy to 54 over 99. Now, I expect you're thinking, how do you know that will repeat, Mrs. Brown? But I do. Sydney, what is it? 0.54 repeating. Whoa! The two digits that repeat were Miles's favorite number. It's like math magic there. There were two of them. Griffin?
So anything divided by 99 repeat?
Yeah. Did you hear that moment, kids? Griffin just said anything divided by 99 repeats. Let's test it. Nick, your favorite number? 26 over 99. Test that in your calculators, kids. I heard a whoa, that's a good. Did you get 0.26 repeating?
Yes.
Wow. Trent, your favorite number? 52 over 99. I'm glad all of us are growing up here a little bit. What did we get? Do you think that these are coincidence? No. Except the two middle ones were not over 99, were they? But if we look, and everybody look, I'm going to show you. This is neat. The first one, over 99, would you agree it had two things that repeated? The last one, over 99, had two things that repeated. If they were just over 9, how many things repeated? 1. So just over 9, just one thing repeated. So without your calculators, what if I gave you 7 over 9? 0.7 repeated.
I just well, it's always the top number.
Yeah, and it's always your numerator that repeats. Kind of cool, yes? Learning something. So to summarize all that, because let's face it, there's always a pattern in math. 0.4 repeating gave us 4 over 9. 0.45 repeating gave us 45 over 99. Watch this. This is cool. 0.456. How many things are repeating there? 3. So what did it have to go over? Yeah, 3 9s. And then if I wanted to get even more wild and crazy, 0.4567 over 9,999, because would you agree 4 things repeated, so I needed to put it over 4 9s. Okay, you guys are really quite... Okay, so we got to answer these questions. Can you see any pattern? Repeating digits become the numerator. And the length of the period, or the length of the things that repeats, determines how many what are in the denominator. How many 9s? So let's try, I need somebody's favorite number. We're going to do 3 of these. Don't flip your page yet. You're going to write them. Trent? 68. Trent, watch this. I'm going to go 68, 68, 6. Over 9,999. Actually, no, I don't like that one. Sorry. Not sorry. I want them to be different digits. Let's say Miles, favorite number? 70. And I need somebody's favorite single digit number.
6.
Go 4. What do you think would happen if I did this, kids? 68,704 over 99,999.
It was 0.68,704. Repeated.
Yeah, the whole thing would repeat. Wild, right? Okay, I'm going to see who is on their toes right now. I heard somebody out there in Mathemagic Land say that 6 was their favorite number. But this time I'm going to make it 6 over 99.
0.6.
Yeah. Sydney just did something brilliant. She said, in order to figure out what repeats, we should have the same number of digits on the front or bottom and top. If I add the 0 on the front, is 0, 6 the same as 6?
Yes.
Is 6, 0 the same as 6?
No.
No, so you always add it in front, which means that this guy here becomes 0.06, and the 0 and the 6 all repeat. Okay, what if Griffin, favorite number?
14.
14 over 999. Good, 0.014. And be careful, 3 numbers on the bottom, all 3 things repeat, because we could do that. Cool? How do we feel about repeating numbers?
Isn't it if you put a 0 in front of the number, there's always a 0 in front of the number, but if it's behind the
Yes, yeah, you can always add one in the front. Okay, the next page, oh my goodness, it's already your assignment. But first, I want us to practice this. I want us to see who is the best